doing great. We're here with this 6-7 similar figures.
Which is great as well.
Yeah, similar figures are awesome, by the way, in case you didn't know this. Okay. Anyway, guys, this is more of like what we've been doing. Find a sequence of transformations that moves one figure onto the other, right? I mean, that's as simple as I can say it. So we've got two figures here. It says, hey, we're given the fact that ABCD, that's the blue trapezoid over there, is similar to EFGH. Describe a sequence that maps or moves ABCD to EFGH. So we need to make the blue figure turn into the red figure. Okay, so I'm not very smart, but it looks like it's going to have to get bigger. So I'm assuming we're going to have to do some kind of a dilation. And look, it gives us the moves, guys. We just have to figure out reflection across something, translation. Okay, so let's do this. All right. Again, first thing we always like to check is the order, right? Orientation. A, B, C, D, E, F, G, H. Right. So E, F, G, H is my order there. We look over here at this trapezoid, A, D, C, B. So we know we have to reflect. That's why they put it here first, to get the reflection out of the way. I'm assuming, folks, now we could reflect over a lot of things. It's probably easiest for us just to reflect over the y-axis here, okay? So A is going to move over here. I don't think they did that, but whatever. B is going to move right here. So here's A, here's B. We should probably make this in a different color. Here, you know what? Now, who cares? A, right here. B, I was going to make it a different line of reflection so that we could go units right and units up. What are they? Whatever. All right. D, let's see. D is going to be all the way over here. And C is going to be right here. Okay? All right. So there we go. So we have now reflected across the y-axis. Okay. Let's go ahead.
Translate. I think you need to translate
Yeah,
right 2 and up 3.
Yeah, we're gonna have to move it up here because then we're gonna dilate it and make it larger. So we're gonna have to translate 2 units to the right and 3 units up.
Yeah.
So 2 right, 3 up. So here's A. Here's let's see, B. C. D. Boy, this is really getting messy. No, this is getting a little messy in here, folks. There you go. Okay. All right. And then finally, we have to dilate, right? So let's just look at some different side lengths that we could look at. So we're going to look here. I've got a side length of 4. Here, I have a side length of 2. Now, folks, if we have a side length of 2 and we have to make it bigger and turn it into a side length of 4, what number or scale factor should we multiply by?
2.
That's right. So then we are going to dilate with a scale factor of 2. Okay. Again, is this the only way you could have done this? No. Right? I think for most of us, maybe we would have dilated first and made it the same size, and then we can reflect and translate, and that would have been just fine too. Okay, that probably would have been my vote. Okay, but hey, it all works the same.
Yeah.
Next one. Here we go. If triangle PQR were similar to XYZ, what angle would correspond with Q? So Q, guys, is the middle vertice in PQR, so it will correspond to the middle vertice in XYZ, which of course is the letter Y. So it would correspond to angle Y. Now, are these triangles similar? Well, they certainly look like they're both right triangles, okay? So, guys, is there some kind of a sequence that we can make blue triangle turn into the red one? Or really the red one, Mr. Noel and I were debating this earlier, or the red one into the blue one. Who really cares? I'd say, you know what, let's make the red one into the blue one, shall we?
Yeah.
Look, it doesn't really matter. All right, so
I like
the first thing I want to do is I would like to dilate, right?
Great choice.
So y to z, right, has to correspond to QR, okay? So this has a side length of 3. This has a side length of 2. So I need to shrink a side length of 3 down to a side length of 2. What number do I need to multiply by, right? This is my scale factor. It's not a trick question. It's just 2/3, guys, all right? So I'm going to assume that, yes, our triangles are similar. So the very first thing I would like to do is dilate by 2/3, okay? What will that do for me, you ask? Well, that will make my triangle smaller, okay? So point X is right here at 3, 3. So X is at 3, 3. When I multiply by 2/3, okay, what happens? Well, X now moves to 2, 2. Sorry, this is 3, -3. Good catch there. So this is going to be 2, -2. So X is going to move here. Okay, Y is all the way down here at 3, -9. So this is 3, -9. This is going to move, let's see, again, multiply each one by 2/3. This is going to move to 2, and then that's going to be -6. So 2, -6. Okay. Point Z, right, is right here at 6, -9. Again, multiply each one by 2/3, right? This is going to turn into, what is that, 4, and this is -6. So 4, -6. All right? Make that point go away, make this go away. All right. So, Mr. Knowles over here laughing at me. You believe this, folks? All right, so guys, that's the only thing I've done so far. So all we did, dilate this red triangle by 2/3, it moves here, okay? Now look, they definitely look like the same shape and size. I'm thinking we probably could rotate. Now, do we rotate clockwise? No. But I'm thinking, because look, guys, X, Y, Z, X, Y, Z. So look at your orientation. X, Z, Y. And this is P, R, Q. So my orientation is good, meaning I don't want to reflect. So let's rotate from quadrant 4 through quadrant 1 through quadrant 2 into quadrant 3. So if I'm rotating 3 quadrants, that's a 270-degree rotation, okay? So we're going to dilate by 2/3, and we are going to rotate 270 degrees.
Yes!
Do you want to check a point just to make sure that it will indeed rotate? Well, we certainly could.
Might as well. We got all the time in the world.
That's right. So guys, point X and point P need to be in the same spot. So point X is at 2, -2. Now, if we rotate 270 degrees, right? What's our 270-degree rule? Right? That says, hey, take your ordered pair.
Flip them.
Yep, and they're going to change to y, -x. Okay? So if we rotate this 270, flip them, so now it's -2, 2, and then the x value, this second one's got to change to its opposite, so -2. Now, is this where point P is? -2. Oh, it is!
Yes!
Ew. Okay, so
Boom.
there we go.
This
So
guy's good.
we could rotate the other 2 points as well, Y and Z. They're both going to turn in here to Q and R. So there's our 2 moves, gang. Dilate 2/3, rotate 270. We are good to go. Okay?
That is awesome.
Again, these questions take a little bit longer. Okay? So just because they're going to take longer, don't give up on us here. All right, quadrilateral. Here it is, RSTU. Translated 6 right, 4 up, then dilated by a scale factor of 1/2. Graph the resulting similar quadrilateral. We just have to move this one. You guys think we can do this?
Yep.
I would hope that we can. So we need to take these 4 points, these 4 vertices, go 6 right, 4 up. Okay, so I'm going to go 1, 2, 3, 4, 5, 6 right, 1, 2, 3, 4 up. Here's S. 6 right, 4 up. 6 right, bloop, 4 up. There it is. This one's going to go 6 right. 1, 2, 3, 4, 5, 6 right, and 4 up. 1, 2, 3, 4. That one's got to be here. There we go. Okay? So here's my... Ooh, that is not a good line. Let's try to redo that. There we go. Much better. Okay? So definitely has the same size right now. We're going to do the scale factor of 1/2. So we kind of need to look at our points. So here's T. You know, I'm going to try to not do all the points in here because it's just going to get jumbled up. Okay? So here's S. This is at -10, -2. Okay? When we multiply each one of those by 1/2, this turns into -5, -1. Right? So we're going to go, we'll make this in blue. -5, -1. There you go. Got it here. Let's do this point down here. -10, -10. -10, -10. Again, multiply each one by 1/2, -5, -5. Right here. All right. We can do point T, which is this point right here at -2, -2. -2, -2. Multiply each by 1/2. You guessed it. It turns into -1, -1. Our last point, guys, is going to go right here at -1, -5. And here is our new similar square, or as they say, quadrilateral. Okay? Again, if they give you 2 moves, just do them in that order. Okay? That's where it ends up. Number 4, describe a sequence of transformations that shows triangle NOP is similar to triangle QRS. Sounds good to me. Let's go red to blue. Again, if you wanted to go blue to red, you could. So I think the first thing that I think we need to do, probably, gang, is rotate down here. Again, you can check the orientation. NOP. NPO if we're going this way. Now, if you were to go, counterclockwise, it's in that order, NOP. So let's go counterclockwise here, QRS, good to go, all right? So orientation is the same. That means no reflection. All right, so I want to rotate just one quadrant down here. That's all I want to do for starters, okay? So we're going to rotate 90 degrees, okay? We need our 90-degree rule, right? I'm going to make some room over here on my quadrilateral. That is now gone, okay? Our 90-degree rule says take your ordered pair, and it turns into -y, x. Okay. So point P right here at -4, 2. Point P, -4, 2. Right? Apply our rule to that. So these two got to switch. This is going to turn into -2, -4. -2, -4. Bam. There's P. O. O is all the way here, guys. -4, 6. -4, 6. Again, apply our rule. This turns into -6, -4. -6, -4. There's O. N is our last vertex in the triangle, and that would be at -1, 6. Again, apply the rule. -6, -1. -6, -1. Here it is. All right, and this is N. Okay. All right, so there you go. Our triangles are getting closer. Okay. I think the last thing that we need to do. Anybody know? Dilation. That's right. We got to make them the same size. So
absolutely.
Let's look at any of our. Again, look. We should know we're going to get bigger. Got to be a number greater than 1. So I'm going to look at this side length here. This is R and Q. 1, 2, 3, 4, 5. This has a side length of 6. 1, 2. This has a side length of 3. So guys, if we need to make that triangle side length go from 3 to 6, what should our scale factor be? 2. That's right. So we're going to rotate 90 degrees, dilate from the origin by a scale factor of 2. Remember, R is the same thing as scale factor, okay? We do that, we're good to go, right? I could prove to you by taking these ordered pairs and multiplying each one of them by 2, they will go exactly where Q, R, and S are, okay?
Sweet.
I know this is taking a while, folks. Stay with me. Don't worry. Due to time constraints, we're going to skip that question down there. But we're going to do this one. What angle corresponds to angle S?
Oh, that's easy.
This is real easy. So again, angle S is right here. I mean, it's got to be the same as that second letter in, which is angle X.
That was easy.
Describe a sequence of transformations, right? That shows these two quadrilaterals are similar. Again, look at orientation. RSTU. Look, I'm an alphabetical person, so I'm just going to go in whatever order. So look, I'm going to go RSTU. So I'm going this way. Okay? RSTU. Start at V, XYZ. V, Z, Y, X. Is my order the same there? It's not. So dead giveaway. We've got to do Mr. Knoll's favorite transformation, and that is a reflection. So that's the very first thing we're going to do here.
Ooh, are you? I would dilate first.
Now we're going to reflect it.
You're going to reflect it? That's okay, too.
Yeah. Well, if I dilate it, Mr. Knoll, I don't have enough room on my graph here.
Well, I'm saying take the blue one and dilate.
Oh, you could. Well, we're going to go red to blue.
You're going red to blue?
Yeah, we're
All
gonna.
right, I was thinking going blue to red.
And see, that's why we're opposites. You know what I mean? So, guys, we're going to reflect just right over our y-axis right here. Okay. Again, super easy. So that means R is going to move here. U is going to be here. T going to be right here. And S is at 3, so it's going to be over here, -3. Okay? There you go. All right. So we reflect, bam, R, S, T, U. Right? My orientations are good now. We could do a double check on that, as I know you will. Let's look at side lengths now, because now I think the last thing that we need to do is say, okay, yep, so this side length on the bottom is 2. This side length right here, 1, 2, 3, 4, 5, is 6. So if I need to make, right, my quadrilateral bigger, could go from a side length of 2 to a side length of 6, what should my scale factor be? What's 6 divided by 2? That's right, it's 3.
3.
So we need to dilate from the origin by a scale factor of 3. Okay? And then we're done. Again, we could double check this, right, by saying, okay, yep, point S is right here at -3, 1. And if we multiply each one of those, well, -3 times 3 is -9. 1 times 3 is 3. And that's right here where point X is at -9, 3. Okay? So again, that works out just as well. Bam, those two moves. Okay. Question 6, thanks, but no thanks. And moving on here to question 7.
One more time, baby.
Yeah, again, the common theme, are these two quadrilaterals similar? So given RSTU is similar to VXYZ, okay? Describe a sequence that maps them together. So, guys, you saw me drawing my arrows there to check our orientation. RSTU, VXYZ. Orientation is the same.
Do not reflect.
Yep. No reflection. Okay? So it should be obvious what I need to do now. So it looks like I definitely need to do some kind of a rotation, and I definitely need to do some kind of a dilation to make them the same size. Do you guys want to dilate first? Sure you do. So if we're going to dilate, probably best, right? Let's take this blue one. Let's make it smaller, right? Usually we're making stuff bigger. Let's make this one smaller, okay? So it's the same size as the red one.
Cool.
Okay?
Cool.
So,
I like that.
Yeah, let's look at side lengths. Okay, let's look at are you going to look at the side length? Yes, that means we have to look at ZV, this one right here. So this is a side length of 2, this is a side length of 4, okay?
I see it.
So if we're a side length of 4, but I need to be a 2, we're going to have to get smaller. Again, guys.
Got to multiply by a number
Yep.
less than 1, but greater than 0.
Yep. So dilate by scale factor 1/2. Okay? When we do that, that will shrink this one down, right? Now it's going to get smaller. Okay, so all of these are going to get cut in half. Now, what's the last thing I need to do, right? So again, you guys can all see, okay, yep, this is going to be, somewhere, like here. It's going to be about there. What do you think I need to do now?
That's got to be some type of rotation.
Yep.
And we're rotating from quadrant 2 into quadrant 3. That
So-
looks like one quadrant.
We're only moving one quadrant. We know every quadrant's worth 90 degrees. So we are going to rotate 90 degrees.
Bam.
Okay?
Perfect.
Is that going to be enough, though? I don't think so. I don't think so, right?
Do a little bit more.
Yeah, so guys, that's going to get us close. That's not going to get us all the way. That's only going to get us to, here. So now we're going to look like this. Boom. And then this is going to go like such and such. So now I think we're going to have to translate. We're going to have to go down and left, right?
Down and left.
Okay? So again, we're trying to move this point here to this point here. So let's go left 1. Does that sound good, Mr. Noel? And down, I'm going to say 1, 2.5. Sounds good to me. Bam. Okay? So again, guys, we're just finding, again, we don't look. I've been doing these forever. So for me, it's really easy for me to look at it and say, yep, we're going to have to do these 2 or 3 motions, okay? For you guys, it might take a little bit longer, but that's okay, right? Reflect it, translate it, rotate it, plot your new points, and then see where you got to go next. Remember, there are more than one way to do these, okay? So don't get frustrated. Just work through it. So you should be dangerous enough now for your Math Excel and your bookwork. I'll see you guys later.